Okay, today we're looking at section 13.6, how to use the law of cosines to solve triangles. Okay, so we learned about the law of sines, and we learned when we can use the law of sines. What would happen if I know two sides and the angle in between, like this triangle, and I tried to use the law of sines? Well, I could take the sine of 24 over A and set it equal to the sine of B over 23, like I have in this formula. Problem is I can't solve that because I have two unknowns. Regardless of which ratio I use, I always have two unknowns. So the law of sines is not going to help me in this case, so I need a different way to solve it. So the way we solve side angle side cases is the law of cosines. The law of cosines is in your text. Looks like this. Looks like there's three different equations, but it's all basically the same depending on what you're trying to find. Okay, so the way it works is, let's say I'm trying to find side A, and I know sides B and C and the angle A in between. That's side angle side case. Well, we'd use this formula here. A squared equals B squared plus C squared minus 2 times the product of B times C times the cosine of the angle in between. So the side here is the same as the angle here in the formula. Okay, if I'm trying to find side B, then I'm using the middle formula, B squared equals A squared plus C squared minus 2AC cosine of B. And then finally the third formula if I'm trying to find C. Okay, so I have to figure out which formula I'm going to use and then apply that. So let's try this example. Solve triangle ABC. Let's label that. A is 8, B is 10, angle B is 48. Whoops, this is supposed to be C. Angle B is 48, B we don't know, and C equals 10. Okay, so I have the side angle side case in which I can use the law of cosines for side angle side. So which formula am I going to use? I'm trying to find side B here, so I'd use this one here. So I'm going to go B squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 48. Okay, so now if I was going to put that into my calculator, what I would do, let's just make sure I'm in degree mode. I am. So here it is here. So I'm going 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 48. So I can enter all that in at once. We're getting B squared equals 56.94, and then I take the square root of that, 7.54. Okay. So I've solved side B. Now I still need angle A and angle C, but now I could use the law of cosines, or I could go back and use the law of sines. Okay, so let's just, as a review, use the law of sines. Let's try to find angle A. So we go sine of A over 8 equals sine of 48 over 7.54. Okay, cross multiply. Divide by 7.54. Sine of A. Back to our calculator again. So 8 divided by 0.7885. Take the inverse of that, inverse sine, and it's telling me I got about 52 degrees. Okay. Finally, they have to add up to 180. So it looks like this adds up to 100, so this is going to be 80 degrees. So I've solved that triangle. Okay, so anytime we have two sides and the angle in between, it's got to be law of cosines. Now, when else do we use the law of cosines? Well, what's the one case we have not looked at yet? Well, what if I know all three sides? If I know all three sides, I can't use the law of sines again, because I'll always have an unknown. So A is 14, B equals 16, C equals 9. Remember, the side is always opposite the angle. So we have three unknown angles. So we use the law of cosines. Now, going back to the formula, which formula do we pick? We can pick any of these formulas. Depends on which angle we want to find. So let's use the first one. Let's find angle A. So I've got side A is 14 squared equals B squared plus C squared, so 16 squared plus 9 squared minus 2 times 9 times the cosine of A. Here's my unknown right there. So how do I solve that now? Well, let's square some of this stuff. Here's where we have to be careful now with the math. We can combine these and add these two together, so that'd be 337. So here's where people make a mistake. Don't make this mistake. We cannot subtract these two numbers here. This is multiplication here, so we have to undo this properly. We have to subtract 337 on each side. I believe that's negative 141. Okay. And this is still negative 288 cosine of A. Okay, so now we divide by negative 288. Okay, so let's see. 0.4896. So angle A is the inverse of that, inverse cosine. $60.7 degrees. Okay, so don't make that mistake. Don't subtract those because that's attached there. It's multiplication, so we have to undo and divide both sides once we isolate this part of it. Okay, so we've got angle A. Now we have to find the other two unknowns. Okay, we could go law of cosines again, or we could go law of sines again. Okay, so let's, as a review, let's find, let's use the law of sines for angle B. Sine of B over 16 equals sine of 60.7 over 14. So multiply both sides by 16 times 16, those will cancel. So let's see. Looks like I get 0.996. So angle B is 84.9 degrees. And then finally angle C, I can just subtract those from 180. .4 degrees. Now make sure and look and make sure the smallest angle is opposite the smallest side, the biggest angle is opposite the biggest side. It looks like it is there. Okay. So when do we use the law of cosines? We use the law of cosines for side angle side and side side side. If I have angle side angle, angle angle side, if I have side side angle, I use law of sines. Okay. What if I have angle angle angle? Well, if I have angle angle angle, three angles, then I cannot find the length of the sides because they could be any length you need to know one of the side lengths in that case because you could have similar triangles. Okay. The only other thing in this section is called Heron's formula, and I'm just going to throw the book up here just real quickly. Heron's formula allows you to find the area of a triangle if you know the three side lengths. Okay, and you just plug the numbers into this formula. Just a tad. Okay, so you can see it here. It looks a little bit complicated. S is called the semi-perimeter, which is half the perimeter. So you add up the three sides, multiply by a half, and that's the semi-perimeter. Okay, that's the S in the equation. The A, B, and the C are just the side lengths. So here's an example, example number 4. You've got a kind of an odd looking block in a neighborhood. You've got your side lengths. We want to know the area of that triangle there. Okay, so they first add up the sides, divide by 2, they get their semi-perimeter, and then plug everything into the formula and make sure you subtract before you multiply. So subtract each side length from the semi-perimeter, multiply the values together, find the square root, and that gives you your area. So it's pretty straightforward, and there's a couple in your homework for you to try. So that is all we have for section 13.6.